All right, today we are going to be starting our first day of our exponent notes. Our goal is to fill in this first side and make sure that we completely understand this because this really gives us the solid foundation of it. So you should have come in and started the warm-up. I do want to make sure I have these answers correct and that you agree with me on that. So if we write something without using exponents, it would be here 2 times 2 times 2 times 2 times A times A times A times B times B. If we look, it just has 4 A's. We got that because it was 2 to the 4th power, 4 2's, 3 A's, so times A, and then 2 B's, so times B. So this one we can write much simpler. This would be 5 to the 3rd, R squared. S, we just have 1. We could write S to the 1st, or most of the time we just write S, and it's assumed that it's 1. And then we have 1, 2, 3, 4, 5 T's. Before moving on, one of the things that I want to make sure we understand is that, like, when I have T to the 5th here, that means that 5 only goes to the T. It doesn't go to anything else there. That's kind of one of the big mistakes that a lot of people think, is they think that that number has to apply to the one in front of it as well. Okay, so understanding a little bit of the vocab that we're going to see. Exponential form just means it will have an exponent with it. So back up to our warm-up. This is exponential form, and this is exponential form. It has an exponent, so anything with an exponent. So let's say 4x to the 5th. And like I just kind of talked about here, what that really means is 4 times x. It doesn't mean that I have 5 4's as well. The base of the number is always the bottom here. So let's say x to the n. This is the base. When we then have expanded form, that's repeated multiplication of the base. So let's go back up here and say, okay, if I have 4x to the 5th, expanded form would be 4x. Now you can put multiplication signs in between. I don't, because it seems like one more step to do. Okay, if I look here, it's just kind of what are these? A is the base, and n is the exponent. All right, so before I go on to the products of power, I kind of want to go over that rule and how it exists. So if we were to just simply, if I give you the problem, 3x to the 4th times 2, no, I don't even want that, sorry guys. Let's do x to the 4th times y to the 2nd times x to the 3rd times y. And I asked you to simplify that. Now the very first step that I'm going to show you doesn't look very simplified, but it's leading into how it works. So if I have 4 x's, it's going to be 1, 2, 3, 4 times 2 y's, 1, 2, times 3 more x's, 1, 2, 3, and times 1 more y. I could write it like that. And again, I could put times signs in between, but we know if they're right next to each other, it means multiplication. Then I can simplify it by saying, okay, how many x's do I have all together? Because when it's multiplication, if it's all multiplication, you can actually change the order that it goes in. So that's kind of what I'm doing right now. Is I'm going to say, well, I want all the x's multiplied. Well, if I have 4 here and 3 here, that's x to the 7th. And I have 2 y's here and 1 more, that's x to the 3rd. If you just looked at the problem and said, how do I get here? If you notice, all we did was add the exponents. There's 7 x's, here's 2 y's and 1 more, so y to the 3rd. So really, when you're multiplying things that have the same base and different exponents, we just add the exponents. So let's practice on our notes then to make sure we understand that. So here it says I have 3 s's, 2 more make 5, 7 more makes 12. So I have s to the 12th. Here, the biggest mistake people do is they want to change the base. The base never actually changes, it's just the exponent. So I'm not going to really do 10 times 10, I'm just counting how many do I have. I have 5 10's here, and I could have 1 10 here, so I'd write it as 10 to the 6th. Here, A's get to go with A's, B's get to go with B's. So I have 2 A's and then 7 more, so I have 9 A's, so A to the 9th. And I have 4 B's and 8 more, so B to the 12th. Last one, don't let a negative throw you off because it's still the same idea. We just add them. So -1 and 3 makes 4 to the 2nd. If you wanted to be really good and write it as 16, that'd be fine too. Okay, so when we have this, it says the blank the exponent of powers with the base. So we add the exponents of the power with the same base. Again, that's key. It has to be the same. I couldn't here put this as AB to the 21st. They have to be separate. So we just pretty much add them with the same base. Okay. Now, I'm going to show you again a little thing for our next one here. Is if I asked you to do what is 10 divided by 10. I hope most of you be like, oh yeah, I know that's 1. Okay, if I said 36 divided by 36, that's 1. Or x divided by x is 1. So really the key here is that anytime I have the same on the top and the bottom, they cancel out and create 1. So if I gave you x to the 4th, y to the 3rd, over x squared y. So I'm going to write that out in our long form just to kind of show our rule again. So x to the 4th, that means I have 4 x's. Y to the 3rd means I have 3 y's. All over x squared and a y. Well, we just talked about if I have x over x, it creates 1. Well, isn't this an x over x? So that really creates 1, so those go away. I have another x over x, so those create 1, so that goes away. And I have a y over y, which is also going to create 1, so that goes away. What I'm left with then is x squared, y squared. If you look, all we did was subtract them. 4 minus 2 is 2. 3 minus 1, again, remember if there isn't a number, it's 1, is 2. So it has to be with the same base, but we really just subtract them because they undo each other or cancel each other out. So going here, if I have 11 2's and then 3 2's, again, remember our base doesn't change. 11 minus 3 is 8. Okay, this one I'm going to zoom in a little bit. It's a little harder to see here. Here, we're going to do each one as a piece. So I have 7 on the top and then 5 on the bottom. So that leaves me with 2, because 7 minus 5 is 2. 3 minus 2 is 1, so I'm just going to write that as k. And then 8 minus 3 is 5, so m to the 5th. Okay. We've got this one. All we have to do is subtract. So 3 to the 2nd power, because 12 minus 10 is 2. Quick reminder, base stays the same. All right, here, it doesn't matter that they're not lined up. We still do the same thing. 1, we keep negative 8 where it is, because that has nothing to cancel out. If I look at these, 9 minus 2 is 7. And then 10 minus 4 is 6. I am going to add in an extra one here that I just kind of want us to be aware of, is if we had, let's do 36 x to the 5th, y to the 10th, and I'm going to throw in a z here, z to the 4th, over 12 x to the 3rd, y to the 10th. And I asked you to simplify that. The reason I put this on here is this is what throws everybody off. Is you're like, oh yeah, I know I subtract, but we don't subtract this. We think of this as a regular fraction. So if I just had 36 over 12, we would think, okay, can I simplify that? Yeah, they can both be divided by 12, which really would create 3 as a whole number. Then I'm going to use my subtraction. 5 minus 3 is 2, so x squared. Here's the other thing I wanted us to focus on. If all the y's disappear, do you agree they all canceled out, kind of like we showed at the beginning, like x over x, y over y? It's going to completely cancel each other out, so I don't need to write anything because it made them all disappear and created 1. And then I'm just left with z to the 4th because there's nothing to simplify that with. All right. Okay, this then leads us to our next one. So our 0 exponent rule. If I have x to the 3rd over x to the 3rd, we could think of that as, okay, I've got 3 x's. I got the same thing on the top and the bottom. They all cancel out, so it makes 1. Do you also agree that if I do 3 minus 3, I get 0? So what that deduces us to is anything to the 0 power is 1. A different way to show why that works is if I were to make a table here, and here I would have 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. 2 to the 1st is 2, 4, 8, 16, 32. Now I don't memorize these, I just know it's always the previous 1 times 2. So if I want to go backwards, I'm dividing by 2. So if I have to go 2 to the 0, 2 divided by 2 is 1. So really anything, again, to the 0 power always is 1. So when we look at these, oh, I'm so sorry, I forgot to go back here. Oops. On this one, we subtract. Sorry, you know how my mind works. The exponents to the power with the same base when it's division. Okay, here. Any term raised to the 0 power is equal to 1. So what that means, this little piece right here is 1. So this is just 5x. This one looks tricky, but the whole thing is to the 0 power. So it doesn't really matter what happens in here. I just know it's 1. Okay, this whole thing becomes 1. Then I've got 9 x's and just a y. You wouldn't have to have the 1 there if you wouldn't want to. And our last one, this whole thing to the 0 power is 1. So then times 4 must be 1. Careful, a lot of people want to say that 0 times 4 and it's 0. So, all right, good luck.